Alright, in this lesson we will practice a little bit more solving equations that have variables in the exponent. And the key is that it's all about getting the bases to be the same. You're going to want to have your a table of exponential values ready. One of these will be extremely handy. Alright, problem number 1. I see you have a 5 and a 25. Alright? Obviously 5 is already its own base. It can't be broken down any further. It's a prime number. But 25, if we could write this as a base 5, that would be great. So I could rewrite this problem. I've got my 5 over here. Alright? But 25 can be written as 5 squared. Alright? No problem. And now I've got my 3x plus 1. I'm just going to bring that down. But here, don't forget I've got this x plus 1 that I've got to deal with. I will put that in parentheses. I'm going to have to distribute that later. So that's going to give me 5 to the 3x plus 1 power equals 5 to the 2x plus 2 power. Now, since the bases are the same, logic dictates that the exponents must be the same. So 3x plus 1 must equal 2x plus 2. So to solve this, I need to get the x's together by subtracting 2x from both sides. So that'll give me x plus 1 is equal to 2. If I subtract 1 from both sides now, that's going to give me x equals 1. Alright, and that will be the solution to number 1. Looking at number 2, just watch out. Because we have this 1/4, we really don't want to deal with fractions like that. So before I do anything else, I would convert this if I were you. Here's what I mean. 1/4, please remember that 1/4 is the same thing as 4 to the negative 1 power. Alright, let me just do that a little bit differently. So 1/4, right, just focus on that. 1/4 is the same thing as 4 to the negative 1 power. Think about it. If I gave you 4 to the negative 1 power and I said write this without a negative exponent, you would go, oh, you just drop it down and it becomes 1/4. Well, we can go back the other way if we really want to. And this is what we want to do because we want to really get to a base and a power situation. So far this is what we have, 4 to the negative 1 power. We still have this x minus 1 up here, which I will put in parentheses. X minus 1 equals 2 to the 2x power. Alright, the bases are not the same yet, but let me deal with this for now. So this will be 4. I will distribute this minus 1. So that's going to give me negative x plus 1. Okay, equals 2 to the 2x power. Now I need these bases to be the same. I can't do anything with the 2. 2 is already a prime number. But 4, yes, a common mistake. Some kids will try to turn this 2 into a 4 somehow. You can't just magically turn this to a 4. This, we can rewrite it as base 2 because we know that 4 equals 2 squared. So I can make this replacement, but I'm not magically just changing it to something else. So if I make that replacement, if I replace this 4 with 2 squared, then this becomes 2 squared. See that negative x plus 1 power? It's still there. So negative x plus 1 is equal to 2 to the 2x power. So this will be 2 to the, going to do the distributive property. So that'll give me negative 2x plus 2 equals 2 to the 2x power. Okay, now that the bases are finally the same, logic tells me that the exponents must be equal. So negative 2x plus 2 should equal 2x. I will solve this by adding 2x to both sides. So that'll give me 2 equals 4x. To get x by itself, I need to divide by 4. 2 over 4 is 1/2. So that gives me x is equal to 1/2. All right, and that's the answer to number 2. I see the 9 and the 3. These can both be written as base 3. All right, there's nothing I can do with the 3, that's already a prime number. But 9 can be written as 3 squared. So 9 will become 3 squared. And then I've still got the x there. And then over here I've got 3 to the x plus 2 power. I just copied that down. So the main thing is 9 is 3 squared, so I can make that switch. Now the bases are the same already. So that means the exponents must be the same. So that means 2x must equal x plus 2. Subtracting x from both sides gives you x equals 2. So that's it for number 3. Number 4. These can both be written as base 2. 4 can be written as 2 squared. And then I've still got the 3x sitting there. All right, this stays the same, so x plus 1. Now that the bases are the same, the exponents must be the same. So that means 6x, all right, I just went ahead and multiplied, should equal x plus 1. Subtracting x from both sides gives me 5x equals 1. Now, to get x by itself, I need to divide by 5. Okay, and that is going to give me x is equal to 1/5. All right, number 5. All right, well, I see that base 2. All right, that's so tiny, there's nothing that I can do with that. So I'm definitely going to have to deal with base 2. So hopefully 16 can be written as base 2. All right, so look there. 16 is, I'm sorry, I'm looking in the wrong place. So base 2, and there's 16. So in other words, 2 to the 4th power is 16. 2 to the 4th power. So instead of 16, I can write 2 to the 4th power, just like that. And then I still have my x minus 2 sitting there. Okay, so that's going to be 2 to the x plus 7 is equal to 2 to the 4x minus 8. You know, distributive property. Now that the bases are the same, the exponents must be the same. In other words, x plus 7 must equal 4x minus 8. Subtracting x from both sides gives me 7 is equal to 3x minus 8. Okay, adding 8 to both sides gives me 15 is equal to 3x. And then we will divide by 3. And that's how we find out that x is equal to 5. All right, number 6. 5 is a prime number, so that won't be changing. But 25 can be written as 5 squared. So since the bases are the same, then the exponents must be the same. So 3x must equal 2. Divide by 3. And we see that x is equal to 2/3. All right, number 7. All right, let's go for a base 10. So we will have 10 to the x minus 3 power. Now 100 is 10 squared. So 10 squared. And then I still have my 4x minus 5. So that means I have 10 to the x minus 3 power equals 10 to the 8x minus 10 power. Distributive property. Now that the bases are the same, the exponents must be the same. So x minus 3 must equal 8x minus 10. I would subtract x from both sides, which gives me negative 3 is equal to 7x minus 10. Adding 10 to both sides, this gives me 7 is equal to 7x. Divide by 7, and you get x is equal to 1. Alright, both of these can be written as base 3. So I've got 3 to the x minus 7 power, and 27 is 3 to the third power. So that means 3 to the x minus 7 power is equal to 3 to the 6x power. Alright, if the bases are the same, then the exponents must be the same. So x minus 7 must equal 6x. Subtracting x from both sides gives you negative 7 is equal to 5x. Then you divide by 5. Oh man, that's a terrible 5. So that leaves you with x equals negative 7 over 5. Alright, number 9. A common mistake would be to try to write these both as base 4 somehow. 4 to the 2x is equal to 4 to something. But this is a fail because 4 to what power gives you 8? 4 to the second power? No, 4 to the second power is 16, not 8. Alright, so you cannot use a base of 4. So if you tried to do that, then that's what you did wrong. Instead, both of these can be rewritten as base 2. I mean, look at the chart. If you look at base 2, 4 and 8 can both be written as base 2. So that's what you got to do. 4 is 2 squared. 8 is 2 to the third power. So that's how you rewrite 4 and 8. And of course, we still got the 2x and the x plus 1. So that's going to give us 2 to the 4x power equals 2 to the 3x plus 3 power. Distribute. Now that the bases are the same, the exponents must be the same. So 4x equals 3x plus 3. Subtracting 3x from both sides gives us x equals 3. Alright, number 10. Alright, remember what I showed you the last time we had a fraction like this. We're going to wind up doing a negative exponent here. So I've got 3 to the 2x plus 4 power. But 1/9 is the same thing as 9 to the negative 1 power. Okay, so we might as well do that. So far, that gives me 3 to the 2x plus 4 power equals 9 to the negative x minus 2 power. I had to distribute that. Alright, but the bases are still not the same. So I need to go all the way down to base 3 now. So this is 3 to the 2x plus 4 power. But 9 is 3 squared. Okay, so that'll give me 3 to the 2x plus 4 power is equal to 3 to the negative 2x minus 4 power. All right, I'm distributing. Finally, so since the bases are now equal, that means the exponents are equal. So 2x plus 4 should equal negative 2x minus 4. I would pull these x's together by adding 2x at both sides. So that'll give me 4x plus 4 is equal to negative 4. Then I would subtract 4 from both sides. So that would give me 4x is equal to negative 8. Finally, I would divide by 4. So x is equal to negative 2. All right, number 11. All right, I see this 2, so I'm going to have to work with a base 2. So I've got 2 to the 4x power. So I'm hoping 32 can be written as a base 2. So there's my base 2, and there's 32. So it's the 5th power. So 32 can be written as 2 to the 5th power. Then you've got your x minus 1. So that means 2 to the 4x power is equal to 2 to the 5x minus 5 power, because you distribute. Now that the bases are the same, logic tells me that the exponents must be the same. Now, I would get these x's together by subtracting 5x from both sides. So that's going to give you negative 1x, or just negative x, is equal to negative 5. And if you want, you can look at this as dividing both sides by negative 1. Right? So that'll make it a positive x is equal to positive 5. All right, last one. Number 12. We can make these both base 9. I could make them both base 3 also, but 9 will work just fine. So 9 to the 2x power, because of course 81 is 9 squared. All right, put that in parentheses. So this will give me 9 to the 2x power is equal to 9 to the 4x minus 6 power. If the bases are equal, the exponents are equal. So 2x should equal 4x minus 6. Let's get these x's together by subtracting 4x from both sides. So that will give me negative 2x is equal to negative 6. And in the last step, we will divide both sides by negative 2. So that will give me x equals positive 3. And that should be your answer to number 12. And that is the last problem on this lesson. I hope it was helpful. I will see you on the next video.